So the last thing we're going to do in this section is actually an application of projections, and it's related to work. So we'll start by saying that the work W done by a constant force F as its point of application moves along the vector PQ is given by W. It's the dot product of the force vector and this vector PQ. Or another way we can say it is it's the magnitude of the projection of F onto PQ times the magnitude of the vector PQ. So let's look at an example here. Let's say to close a sliding door, a person pulls on a rope with a constant force of 50 pounds at a constant angle of 60 degrees. Find the work done in moving the door 12 feet to its closed position. So I am going to give you a picture so you can kind of hopefully see what's going on. Here's my door. Imagine it's a big barn door here. And we want to move it from here to here. So here's P, here's Q. And this distance right here, this is 12 feet. And here I am pulling on the door this way at an angle of 60 degrees. Here's my force vector. So then I'm going to project this vector, this force vector, onto my vector PQ. So right here, this is the projection of F onto the vector PQ. So if I look right here, I have a right triangle, and so I know cosine of 60 degrees, it's adjacent over hypotenuse, right? So it's the length, adjacent would be the length of this projection of F onto PQ over the length. The hypotenuse is the length of the force, magnitude of the force. So if I cross multiply here, I'll see that the projection of F onto the vector PQ, the length of that is cosine of 60 degrees times the magnitude of F. Well, cosine of 60 degrees, that's 1/2. And the magnitude of F, they tell me, is 50 in the problem. So this is 25. So we're going to go back to our force, or our work formula. We're going to use the second one. Work is the magnitude of this projection times the magnitude of PQ. So this is 25, and the magnitude of PQ is 12. That's the distance there. And so it's 300, and if we put units on it, it would be foot-pounds. So that's the amount of work done.